Good day, my listeners and viewers, far and near, home and abroad. It is my pleasure coming before you again in another physics class. And this afternoon, what we shall be considering is velocity time graph. Velocity time graph. What is velocity time graph? A velocity time graph is a graph of velocity plotted against time taken. I take that again. The velocity time graph is a graph of velocity plotted against time taken. That is, we have the y-axis and the x-axis. In this instance, this y-axis will represent your velocity, while the x-axis represents your time. Your velocity is in meter per second, while your time is in seconds. So, when you have velocity against time, this place will give you acceleration. That's meter per second square. If the acceleration continues uniformly for a particular time, that means we have a uniform velocity. If there's a decrease, time t here in seconds, if there's a decrease in the acceleration for another time, that will be deceleration. That will be deceleration. So, the area under the line, this shape, the shape will be trapezium or triangle. The area under the line of the graph measures the distance traveled by the object. So this is what velocity time graph represents. We can as well have distance time graph, where you have your distance d here in meter, and you have your time in seconds. If you have a particular distance covered per time, this place will give you velocity or speed, which is in meter per second. So this one is distance time graph. So if you have distance time graph, you use it to determine your velocity. If you have velocity time graph, you use it to determine your acceleration. Let's consider a typical example under that. Alright, before us an example for consideration. We have a train starts from rest. A train starts from rest and accelerates uniformly. Accelerates uniformly at the rate of 2 meters per second squared. So that means you have A train starts from rest and accelerates uniformly at the rate of 2 meters per second square. This is your velocity meter per seconds, and this is your time per seconds. So it accelerates uniformly at 2 meters per second square. Acceleration is 2 meters per second square. So until it attains a maximum velocity in 20 seconds. 20 seconds. It maintains the velocity for 60 seconds. For 60 seconds. So add 60 to 20. That's 80 seconds. And then it acts uniformly to rest after a further 20 seconds. After a further 20 seconds, add the time. That will give us 100 seconds. 100 seconds. So, you have to find the maximum velocity reach. Find the maximum velocity reach. Velocity reached. The velocity reached. So if you have to determine the velocity, use the triangle. This is 2 meters per second square, and there is 20 seconds. This is the velocity reached. So with what we have here, we have the time and we have the acceleration. If you want to use the formula to find the velocity reach, using this triangle, according to this triangle, we have this side and this side. So, since we have this side and this side, where acceleration is equal to velocity over time, that means your velocity is acceleration times time. Your velocity will be your acceleration 20 times 2. So the velocity will give us 40 meters per second. 40 meters per second. You multiply 20 by 2. Acceleration times time will give you 40 meters per second. I want to believe that is taken. Alright. And then we want to find the retardation. We want to find the retardation. Question 2 asks us to find the retardation. The retardation. Okay. Using this triangle, we have this case as the retardation. You have 80 seconds here, and you have 100 seconds here. Between 80 seconds and 100 seconds, this will be your T1, this will be your T2. So, we've already known our initial velocity. Initial velocity we arrive at is 40 meters per second. Since we are told that it returns to rest, that means final velocity V2 will be 0 meters per second. Initial velocity that it maintains was 40 meters per second. Time T1 is 80 seconds. Time T2 is 100 seconds. So by that, you can determine our retardation. So now applying the formula, acceleration is equal to V2 minus V1 all over T2 minus T1. Our V2 is 0, our V1 is 40, all over 100 minus 80. That will give us minus 40 over 20. That will give us minus 2 meters per second square. So what indicates that it is retardation is the negative sign that we arrive at with the value. So the negative sign that we got indicates that it is deceleration. It is deceleration. The third question says find the distance covered. The distance covered. So to find the distance covered by the object, you use the formula for the area of trapezium to determine the distance covered. Use the formula for area of trapezium to find the distance covered. The distance covered. The distance covered. We have a trapezium from here to here, that's 0 to 100. So that means from here to here is a 100, that's 100 seconds. The height of the trapezium is the value of the velocity that you got, that's 40 meters per seconds. Then this place is 20 seconds, this place is 80 seconds. The difference between 20 seconds and 80 seconds, that's a 60 seconds. So that means this is your B, this is our B, this is your A, and this is your height. Your height. Where area of trapezium. Area of trapezium equals to half bracket A plus B bracket H. So that gives us 1 over 2 times 60 plus 100 times 40. So that will be 1 over 2 times 160 times 40. So that will give us 0, 4, 640 meters. Determine that by your calculator, cross-check. That will give us, that's a 1 over 2 times 160 times 40. So 160 times 4. Okay. No. 2 in 60. This is 20 rather. So that's 160 times 20. 160 times 20. That's 0, 0, 2, 3. So confirm that by your calculator. 2 in 40 will give us 20. So 160 times 20 will give us 3,200 meters. 3,200 meters. All right. So on the board is an exercises for you to engage yourself with. A car starts from rest after 5 seconds and it accelerates uniformly for 10 seconds before attaining a speed of 20 meters per second. If it attains this speed if it maintains this speed for the next 5 seconds, determine the uniform acceleration, the total distance, and the average velocity.